everyone, thank you so much for tuning in. I'm excited for this talk because I've seen so few conversations in data science and machine learning around assessing data origin and historical artifacts. Outside of the data sheets for datasets paper, it's rare to see popular work in ML address past human decisions and how data is just a quantifiable measure of those decisions. We should have a larger focus on why certain decisions were made and understanding if we'd support those same decisions today. So for what we'll cover, I'll talk about what intelligence is and how white supremacy has molded the field of statistics. Then I'll debunk some of the lies you might have been told about big data. We'll then dive into a couple case studies that show this, and then moving into some solutions that require both social and technical expertise to address. Let's talk about discrimination for a moment. In order to truly be accountable for the harm our automated decision systems can cause, we have to acknowledge the historical artifacts of white supremacy and other biases in our data. We must acknowledge which versions of white supremacy are socially acceptable by engineers and society, and that mainly comes from the dominant white culture. This is particularly difficult for creating diverse data teams. It's a massive barrier, and thus it's also hard to create models that are fair across protected classes. And then we want to create equity within these models instead of reinforcing the status quo. But like I said, this is really difficult to do given that our culture of current engineers tend to be white and male. The AI idea we've been sold is a lie. It's represented by smart homes, Terminator, and foreboding overlords when these technological overlords have really been at play for years now. We live in a world where it's normal to be digitally surveilled in nearly every aspect of life. The pandemic has brought us even newer tools for student surveillance. And there are software systems that allow employers to surveil what employees do on work PCs, like watching web usage, what you type, and what kind of files you copy. They even advertise these tools as being stealthy and impossible to detect by employees. We have to also introspect why we speak about intelligence in certain ways. So studies of intelligence and race are really intertwined due to the history and the vast impact of eugenics across the world. Even going back to popular works like the bell curve, we don't really have a great way to measure intelligence without referencing tools created to denigrate and demean Black people. One of the biggest problems that we have is we conflate the idea of IQ with intelligence. And most of the people involved in research on intelligence are either philosophers or eugenicists. And unfortunately, as you'll find out later in this talk, a lot of the founders and fathers of statistics were really proud eugenicists. We have to understand that really data just captures our best representation of a portion of time in the world. It's not really an absolute measure. When we collect and use data about people to really make decisions about them, we have to accept that there can be life or death consequences. It's also easy for us to make new norms or have disparate impact on marginalized groups without legal policy requiring transparency or accountability whatsoever. And unfortunately, we also data weapons. So these are systems that are harming communities by augmenting human decision-making in lending, criminal justice, and surveillance. I'd like for us to pause and kind of reflect on this quote that I really love by Tony K. Bambara. Not all speed is movement. I think that the technology industry has really just accepted machine learning and AI as any kind of innovation is positive without really stopping to understand how we've impacted marginalized communities and people who aren't at the same technological level, people who are left behind on the digital divide as well. And then we also don't prioritize many user groups and people who are just downstream impacted by models, even if they're not a direct user or customer. We have to understand just by collecting large amounts of data doesn't mean that data is predictive or good to use. So why is this such a big deal? Well, unfortunately, the tech industry has accepted scalability and scaling their machine learning models to be the gold star, to be the absolute metric of if a project was actually successful. So unfortunately, in order to do this, we have to have large amounts of data to allow these models to work at scale. And the other part of the issue is that social media has been a new avenue or a new medium for us to have user-generated content. And what's difficult is that when we use and scrape information that have been created by users, what we're really getting is a measure or a metric of what society feels about specific groups. And that is absolutely skewed by the types of users and the types of websites really scraped for this kind of data. It's really hard to fix this problem, especially because so few people have access to data used at organizations like Google and Facebook to make predictions about us. Or even on a public scale, we don't have information about Compass and other carceral and surveillance data sets as a public to really be able to audit and understand this data better. So while there's been a push for cities and federal governments to embrace open data or making vital data sets open to the public, most organizations with the largest impact don't really allow consumers to have this kind of visibility. And ethical groups also advise that companies allow the public to have transparency into which features are important for your model, but really few teams actually do this. Moving into statistics as a whole, I think you'll be really surprised by which kinds of metrics we use today that were actually created by people who had not such a great legacy outside of modern statistics. So unfortunately, a lot of the fathers of stats created these methods in order to actually prove that the white race was superior to others. So what is eugenics? I've mentioned it a couple times and I'll dive in a little bit deeper. It's really a social philosophy that advocated the suppression of reproduction among the unfit and the encouragement of reproduction among the fit. So on a broader scale, trying to weed out, based off of certain biological characteristics, groups of people that were unfit. And unfit for what, I think is a great question here. And really to encourage that people who are fit or of the accepted classes reproduce more frequently. So I want to introduce some of the fathers of statistics you may have heard of, but through some of their work that you may not be familiar with. It's not really easy to kind of purge statistics and data from the ghosts of its eugenicist past. So in even more detail here, I think it's important to understand kind of the concept of both positive and negative eugenics, where the main aspect is the state involvement. So there are some eugenicists who really proposed for enforced eugenics, which meant sterilization, not letting certain groups marry or populate. And there's the hands-off or kind of laissez-faire aspect to positive eugenics, where certain groups are just given more incentives to do things like have children. So I think it's interesting that some of the tools that we've created to measure not just things like customer churn and things we look at in data science really develop to degrade and to incentivize certain groups. So, for Francis Galton, sorry this is really small, but I'll make sure it's a little bit larger whenever you guys get the slides. I know it's important that a lot of the other media you'll see around these people really show portraits of these men, and unfortunately, they do this on purpose. So many times you'll see talks cover old white men with a photo to make us empathize with them, but instead we should look at the impact of their work. So we'll be seeing images that are more representative of the legacy that they left. So Francis Galton actually coined the term eugenics. So this is after he read The Origin of Species by his half-cousin Charles Darwin. And he focused much of his research and scientific publications on eugenics. So he actually became the honorary president of the British Eugenics Society. So yes, he was very pro-eugenics. And then the unfortunate impact is that his work in the early 20th century really influenced and justified acts like forced sterilizations, which happened in the United States all the way up until 1967. And in Canada and Australia, actually happened as recently as 1972. Unfortunately, he also popularized the use of surveys, discovered regression to the mean, and how to apply correlation and regression in anthropology, psychology, and a lot of other industries. He also really defined the concept of standard deviation. So when we're talking about standard deviations, know that the mean, as Francis Galton referenced, is the norm, or what in his time really looked like the average white Anglo-Saxon person. So Karl Pearson was actually a protege of Galton's, and he actually assumed the Galton Chair of Eugenics at the University of London. One quote from him I think is important to call out is, "As an organized whole, kept up to a high pitch of internal efficiency by ensuring that its numbers are substantially recruited from better stocks, and kept up to a high pitch of external efficiency by contest, chiefly by way of war with inferior races." In that quote, what he's actually talking about is the Jewish race, in his words, compared to everyone else. So what he's attempting to say is that they want to recruit better stocks of humans by paying less attention to and fighting literally and being at war with inferior races. It's also important to see that the image on the screen is some of his other work, so the composite portraiture of the Jewish type, from the Life, Letters, and Labors of Francis Galton. So that was a book that Karl Pearson actually wrote about his protege. So unfortunately, Karl Pearson was a noted anti-Semite, who also developed really important aspects of statistics, including p-values, defining what the chi-squared test is, as well as hypothesis testing, which are all methods that we use today to try and understand the data at hand better. And unfortunately, a lot of us do this without truly understanding where these metrics come from. So lastly is Ronald Fisher. So like Pearson and Galton, he was revered. So when asked who the greatest biologist since Darwin was, Richard Dawkins actually nominated Ronald Fisher. So this might not be surprising given Dawkins' own publicized views, but one of Fisher's students actually wrote a brief but glowing biography of his life. And he described Fisher as sweet and nice, and never really mentioned eugenics, and neither did Richard Dawkins. It's really important to understand that Ronald Fisher actually spent a third of his seminal work, The Genetic Theory of Natural Selection, arguing in favor of eugenics. What does get erased from history is their deep involvement with eugenic studies and underlying white supremacy. Racism and statistics do go together in the obvious sense that racists traffic in stereotypes, and statistics is often framed in terms of the average person. Ronald Fisher also held really staunch views on race in the aftermath of World War I, so he actually criticized UNESCO for trying to coordinate a united condemnation of racism, stating his belief that the races differed, so racism was okay. Ideally, statisticians would love to divorce these tools from the lives and times of the people who created them, and it would be really convenient to do so, but, statistics doesn't exist outside of history, and that's not really the case. Ronald Fisher is popular for things like ANOVA, so a really popular time series analysis, time series algorithm that's used in industry today, as well as setting the value of p being 0.5 as the normal threshold. So He also actually developed the iris data set. So when you are working in really popular machine learning libraries and you see this data set, understand that they're not separate from the people who created them. And what image you actually see is outside of the Fisher Hall, actually in London, and it says eugenics is genocide and Fisher must fall, because they still have a commemorative plaque up in his name. So it's important to understand where the lie is. So it's not really isolated. A lot of ethics courses actually still purport the lie that the vast majority of bias that infects machine learning and AI systems comes from data. That's not really the case. So when we're looking at data biases, we can look at solid things like activity bias, which comes from human-generated content. So this is things like Amazon reviews, tweets, Wikipedia entries, things on 4chan, and really only a small proportion of people actually contribute to this data. So that's an area of legitimate data bias. Then there's selection bias. So this can often happen because of feedback loops. This is when a model really influences the data that's used to train it. So in a recommender system, the position of items on a page and the small details like font and images can impact how users interact with the system. And then system drift actually happens when a system is generating data that changes over time. So this can be the addition of new models or user interactions such as liking or sharing buttons, and the addition of a search assist feature. For omitted variable bias, this happens when data generation relies on human input, where the process recording the data doesn't have access to the key attributes. When we look at societal biases and how they enter the data, this typically also happens from content produced by people. So whether it be social media content or curated news articles, for example, the use of gender or racial stereotypes. This can also be considered a type of label bias, but overall is a societal bias. I want to focus on this area outside of the data, because this is where we have to understand that the data itself is not the only place where bias originates in an algorithmic system. It's important to know that this happens everywhere. This can be from researcher choice. So from the choice of an algorithm or the choice and features to select that actually go to train the algorithm, there are so many human decisions that can impact how well our models work and if they actually are working fairly. There's also bias in AI communities. Like what I mentioned with the aspects of white supremacy that are acceptable, all of those aspects are fairly common in most Silicon Valley or most tech groups. And because our group of engineers and data scientists and machine learning engineers comes from typically the white male-dominated kind of culture, we also see a lot of those socially acceptable forms of white supremacy in our machine learning products. Then we also have just biased or unethical business cases. If our objective is to merely surveil groups or to try and inform police officers of how to police, we're going to see the same kind of bias and disproportionate outcomes as we did with typical policing and systems that aren't using algorithms. Then we go into system deployment, which I think we should first change the name of anyway, but when we put systems out into the world and implement them in our products, the way we implement them is actually incredibly important and can encapsulate data, and can encapsulate bias within itself. So if we deploy systems not just with bad use cases, but poorly, so they only work on iOS devices, or they are exclusive of people who aren't within the gender binary, we are then again purporting the same social biases with our systems. And then algorithm selection, I think, is incredibly important to understand, because the type of algorithm that we choose to answer a specific kind of question is going to is going to change how fair we can make a system and what kind of fairness metrics we can then use on that system. What you see here is a slave ledger. So this basically kept track of the attributes of slaves as well as the information about their sales. I want to make sure you understand that data is not neutral. Data embodies politics and societal norms, and it was not collected, manipulated, or leveraged for equal outcomes. When we're looking at historical data, it was almost never actually created to make predictive models out of. We'll never truly be free of the damaging historical artifacts data encodes without abolishing big data. In the US, census data informing about marriages, families, and deaths are all impacted by various public opinions. So prior to 2012, it's not like there weren't any gay marriages in the United States, according to this chart. It's that they weren't recognized because of how society and our law systems didn't recognize the rights of our gay citizens. There were many people in domestic partnerships which enabled some legal protections, and many who were not married, but although they had a marriage-like relationship. It's also important to know that looking at this chart shows us that the public embraced same-sex marriage much quickly than interracial marriage. This also impacts data on relationships and adds to the increasingly common sentiment that Americans have harbored hatred towards marginalized groups. This is important when we're discussing if we should even use human decisions to train machine learning models. So many resources on data ethics and fairness in machine learning gloss over the various reasons for biased models or systems that harm marginalized people. This actually has really large implications. First, it's really hard to work when you have naive engineers, and convincing engineers who maybe are suffering a little bit from the Dunning-Kruger effect and think that they know slightly more than they do. It's sometimes hard to change their mind and show them how they are wrong or that they're encapsulating certain types of stereotypes within their models. We should also address the unequal power involved. Even when we're talking about deploying models, there's no denying that there is a massive power struggle and that users and companies are not at the same level here. Then there's lack of organizational accountability. Engineers really can't change this alone, and it's not their job alone to fix this. But organizational and structural change can help us address the power structures and the disadvantages that we've seen certain marginalized groups face as a result of faulty machine learning systems. So now let's move into some case studies that examine how data sets embody colonialism, capitalism, and white supremacy. First is housing. So there are tons of popular data sets like the Boston housing data set that actually have come under really a lot of scrutiny for having certain columns and features such as the ratio or percentage of the Black population within the neighborhood. It's really difficult because housing is a major cornerstone of most economies, but we also have organizations like Zillow who use all of this past housing data to try and make predictions about future home prices and help people who are appraisers or mortgage companies. Race has unfortunately been used to predict home price though, so this actually was an issue brought up in the scikit-learn data set via GitHub, and really before it was addressed in a tutorial that used the Boston housing data set. So when we think about this, if this was actually used as a teaching material in that time, how many data scientists thought this was an acceptable feature for prediction? We have to unpack our, racist mathematics and tools like statistics in order to dismantle the effect that we actually see in machine learning models. So going beyond toy projects even, production frameworks like scikit-learn and TensorFlow have the Boston housing data set as a standard. So this data set itself was compiled by Harvard and the National Bureau of Economic Research workers for the paper Hedonic Housing Prices and the Demand for Clean Air. So somehow a feature that impacts the price of a home is the proportion of the Black population. So the two, Harrison and Rubenfield, the two researchers that decided to actually create this data set, they appeared to have decided on a threshold for 63%. At which the price of a home tends to decline based on the proportion of the Black population. So at 63% Black or more, you're looking at more of a, in their words, ghetto. It's difficult because this bias data can be leveraged to, expose bias systems, but instead we actually spend time purporting these same stereotypes. So I'd like to see how the housing prices have evolved over decades and then compare that to population demographics to see shifts alongside prices in time. Are Black homeowners being priced out of specific neighborhoods? By doing so, then we can maybe systematically measure how much value the Black community of Boston has lost financially due to this imbalance relative to the average home and home prices in all of Boston. The problem noted is that the column doesn't really include the proportion of Black people. It indicates whether the proportion of Black people is either low or high. In other words, how far from some ideal proportion a neighborhood is. This really represents, though, exactly what society thinks about Black people and race. If you are in a low Black proportion neighborhood, your home price is higher. And I think that's the point. The point I'm trying to make here is that data set has encapsulated that being in areas that have a high Black proportion are negative things for the value of your home. So in hiring, we're also seeing a massive wave of issues related to using machine learning for hiring. So as data analytics are accepted in more and more industries, it's understandable why organizations think automation for hiring is a good decision. The problem is, even data meant to improve diversity can actually have the opposite effect. So in hiring data sets that actually include candidate information, they're almost always privately held by companies, and they don't allow the public to evaluate these data sets. And while few public data sets exist, like the data science job listings on websites like Glassdoor, it's hard to do in-depth studies of the inequality this data perpetuates. It's much easier to find data from developer surveys, but rarely about job candidates. One example, though, is from Amazon. They actually created a tool that accidentally discriminated against women. So the algorithm found that those with women's colleges and women's athletic teams listed on their resume didn't really match Amazon's practices of discriminatory hiring, and therefore they would be less likely to be good candidates than their male counterparts. When we come to white supremacy specifically, we use a lot of algorithms to help people in HR screen different resumes. But unfortunately, we found that people with white and Anglo-Saxon names are actually more likely to get called back for interviews. So similar to eugenicists, there's thousands of recruiters who have personal biases against Black-sounding names and towards white or Anglo-Saxon names. There have been studies that show actually 25% of Black candidates who received callbacks from their white names only got 10% of those same callbacks when they applied for jobs using their real names. So I hate to say their ethnic names because that's not what it is. And I think it's really difficult when we look at this by different racial group. So among Asian people, 21% got called back if they used their white names, and only 11.5% got called back if they sent in resumes with their real names. So how close our names sound to whiteness can literally have an impact on whether we are asked to be interviewed for a job, regardless of how qualified we are for that job. Moving into healthcare. So when we look at healthcare, we really start getting into the impact on patient outcomes, like life or death. So yes, this depends on what kind of data we're inspecting, but the models we build are incredibly fragile to change, especially in healthcare. But we need to be building them with the needs of the marginalized people first. So we've seen massive amounts of disparate impact in healthcare, and this was definitely exacerbated by the pandemic and how we've both rolled out COVID-19 testing as well as COVID-19 vaccinations. Some of the popular data sets that you might have seen or even used in the past for making predictions in healthcare are the Cleveland heart disease data set, the Pima Indians data set, and a simulated fall sensor data set. So a recent study actually examined the effect on care of a widely used but controversial formula for estimating kidney function that by design assigns Black people healthier scores. So the study found that one third of Black patients, and looking at over more than 700 people, one third of them would have been placed into a more severe category of kidney disease if their kidney functions had been estimated using the same formula as for white patients. So this kidney algorithm is one of many clinical decision algorithms that explicitly takes into account race. And in 2009, researchers actually aimed to reduce the disparity between the few examples of Black patients they had and other patients by adding a race correction feature to a Black patient's eGFR, or estimated glomerular filtration rate. So that's just a blood test that measures kidney function. This correction basically boosts that number by nearly 16% in only Black patients, so not even including other marginalized races. So knowing that a low eGFR means you have worse kidney function, we can see how this artificial correction has led to bad outcomes. So this attempt to make an imbalanced data set easier to use by researchers had a drastic impact on patients. In 64 cases, Black patients' scores would have qualified them for a kidney transplant if to be on the kidney transplant wait list, but none of them were actually referred or evaluated for a transplant. So what would you do if your parent was on the kidney transplant list? What would you do if you found out they were less likely to be selected due to their race? A person's race is a social category, not one we should use to interpret blood tests or to balance and rebalance an imbalanced data set because we don't have enough data from specific groups. So even though hospitals like Mass General Brigham, University of Washington, and Vanderbilt have abandoned this race-based eGFR formula, medical societies still have to change their guidelines before most institutions and doctors can move away from using that same calculation. Moving into government policies. So the United States government is far from neutral when it comes to who is excluded. Unfortunately, we've created government policy that's reflecting societal trends and norms rather than what we would like to see. So one policy overturned in the last decade was the U.S. military's don't ask, don't tell policy. So this really barred LGBT members of the military from leading open lives and basically not hiding their sexuality or gender identity at work. Unfortunately, we've made exclusion somewhat of a feature. So with Japanese internment camps and the Chinese Exclusion Act, it's clear that we bake in white supremacy into U.S. policy on a regular basis. This makes exclusion the norm. Understanding how normalized it is to exclude people because of attributes like race and gender are the American way. Even though we don't want them to be, we have to take this to account when addressing power structures and structural racism in this country. From slavery to policy, white supremacy has been a guiding concept for how Americans govern. And knowing that that's baked into our policy, there are things we have to adjust when we're building technology to deal with that. The last case study we have is content moderation. So since the internet has provided us with so much new data, we try to build tools that are technical to address social issues. One of the tools here is content moderation. Groups like Facebook had a large human moderator teams that were subject to vile, hateful, and abusive content consistently. In order to deal with users with bad online etiquette, orgs have started using machine learning to identify harmful content. Unfortunately, like with most language models, there's a lot to get wrong, and what a model classifies as harmful might leverage stereotypes. For example, Black women are most likely to be harmed and harassed on social media. However, we're also more likely to be censored because of the words we use to express anti-racism or homophobia. Ironically, these systems don't really improve the overall social media site, being able to protect the most harmed users from the most harmful users. So this can be former presidents like Trump, or right-wing media with large followings, and the impact and influence to negatively impact users and their human behavior. Instead, the way these companies enforce content moderation is by finding words like gay and queer in a tweet, even if it misinterprets the way those words were used. Black women can tweet something like, "Cis women need to talk more about trans rights," and get suspended, while popular neo-Nazis can tweet, "Go back to your country, N-word," without automatically being flagged. We're turning a corner in society and have a pivotal decision to make. Will we continue to let algorithms run amok at the expense of human life? And we've had at least 3 cases of people being arrested because of faulty facial recognition algorithms in the US. In cases that aren't even life or death within carceral systems, there's serious repercussions to the work we do with data. For example, when we think of data that isn't biased, we may want to reference reinforcement learning. So how can there be negative stereotypes or biases if a robot is just allowed an environment to learn about? If you take away only one thing from this talk, it should be that biases can enter an automated decision system at any point. This can be training data, the composition of the team working on the project, algorithm selection, or many other factors. Take, for example, a robot vacuum cleaner. So in one terrifying case, a robot vacuum cleaner detected hair and sucked up a woman's hair in a country where it's customary to sleep on thin mats on the floor. A device developed in the US may not have included this kind of scenario as a possibility in development. I want to be clear that it's not expected that every engineering team is omnipresent or that we are supposed to know all of this, but we need to address these issues by working with global perspectives, diverse teams, and with social scientists. Don't let engineers and academics perpetuate that the idea that the main source of algorithmic bias is in the data. Data scientists also make mistakes. First, we sometimes just have really bad system design. We have to be more aware of the systems that can harm us, including facial recognition, self-driving cars, hiring, and in credit. We've already seen self-driving cars kill people in accidents, but we don't acknowledge that our roads, infrastructure, and consumer attitudes don't align for true self-driving right now. Yes, we want these things, but there are so many areas where we have to fix and make advancements before we can design technology that works well within these confines. Another aspect is our assumptions. A huge issue is that engineers make assumptions that they're unable to validate. So we are making the decisions on home valuations for Black Americans. Are these aligned with what they should have been? When we are looking at current home prices, and we look at that by race of the homeowner, if we look at the historical data, would they have been evaluated fairly? Or are we able to find financial gaps between how Black families were evaluated and in comparison to how white families were evaluated? And if not, if we don't really agree with how home prices were aligned, why do we assume that we will have equal outputs when our training data is flawed? Flawed assumptions about what the data represents is another massive assumption issue that data scientists deal with on a regular basis. If we can even use specific kinds of data to be predictive, and if past decisions were just drivers for bad decision systems, It's really difficult to make the correct assumption without having a global perspective and an understanding of how different cultures will interpret technology, how technology will be deployed and used in specific systems, as well as details on exactly why a system is automated and isn't left to human decisions. The structure of a model itself matters because they can impact if it works fairly or unfairly. For example, linear regression models can work really poorly for two drastically different populations. And when we're implementing models, we also need to take care that the objective functions are fair. When we're collecting user-generated data from the internet, we should also be able to acknowledge that it's going to be biased in favor of those in dominant groups and show signs of unfairness towards marginalized groups. So why does this happen? Societal biases are reflected in the content of data sets because of many reasons. So unfortunately, many of them can be tied to money and power. Institutions can leverage government policies to invest heavily into surveillance systems under the guise of defense. Governments around the world have been known for their surveillance of marginalized groups, and the power structures around data ownership and privacy make it easy for companies to leverage the stranglehold they really have on consumers. We should also understand the kinds of harm that can be had here. I think this is a great example of both what harms of allocation and representation look like. But there are also harms like quality of service. So facial recognition systems are notoriously bad for people who are women and who have dark skin. If you're a person in that group, you'll definitely see a lower quality of service with products that are using facial recognition than most other groups. Outside of the representational harms, which can be feeling erased by a system or by being underrepresented by a system, there's also lots of systems that reinforce specific stereotypes partly because the data used to train them can be really limited. There's also a massive lack of transparency when we're talking about systems that are in the public sphere and impact people on a daily basis. So a very obvious example of this is credit, and while we do have some transparency because finance is a regulated industry, for most internet companies we don't really see any kind of transparency here. Moving into who gets hurt. The worst part about this is that it's people who are marginalized who suffer the worst implications of algorithmic bias. People who are underrepresented in the data to begin with also see the harshest consequences. When we do things like require certain forms of ID to vote, we make it much harder for formerly incarcerated, elderly, and marginalized people to engage. I mention this because this is not an algorithm, but really an unfair system that could be codified as an algorithm. We should be clear that AI systems and technology in general are never neutral. All AI systems reflect the assumptions, priorities, and values of the people involved in their development. We have to start acknowledging that these systems are political and should rely more heavily on the advice of social scientists. You might be wondering, so how can we start to dismantle white supremacy within data and within AI systems? This is the biggest team effort of our lifetimes. If I'm being specific here, I mean dismantling systemic white supremacy. This shows up in our technology, where we build homes, public policy, voting laws, and nearly every aspect of life. This is terrifying when we have big data sets that capture and perpetuate white supremacy being used to train systems that can make billions of decisions within minutes. To do this, we have to understand the various aspects of the power struggle between privileged and disadvantaged groups. Understanding discrimination requires us to understand power structures. In what ways are you oppressed? In what ways are you in a dominant group? Oppression isn't just about race, but many factors related to non-dominant groups. Keep in mind that each of these factors has a different level of oppression or privilege relative to where you live in the world, and the interactions between these factors can amplify or cancel these out. We want to be able to both identify historical artifacts and then work with social scientists. This is at the core of data science and machine learning and needs to be adopted across the industry. Then we can use quantitative or qualitative data to get better insight on how decisions in our training data were made. When this is sparse, we can spend research and development time to gather external insight and dig deeper into what training data truly represents. The same way big tech orgs lobby for policy that allows them to build surveillance tools and underpay employees by calling them contractors, we can work to impact policy that reduces systemic white supremacy. This can be boycotting products, petitions, working with policymakers on bills. We have a long way to go to at least get something like a GDPR in the United States, but even beyond that, we must accept language around technology that opens the door for non-technical contributors and addresses the root cause of algorithmic harm. As individuals, it may seem as if we have little power when it comes to holding organizations accountable, but we just need to be louder. I want to encourage you to call this out when you see it. The best thing technologists and organizations can do is advocate fiercely for user appeals processes for AI systems and advocate for financial recourse for harmed users. True accountability is flimsy without methods for users to appeal a decision, and in the case the algorithm was wrong, we must find ways to compensate users proportionate to the amount of harm that they faced. I want you to remember that data is not neutral. It was not collected, manipulated, or leveraged for equal outcomes. It should be, but it's not. Thank you so much for listening. You can find me at one of these places on the internet.